Welcome to HACCP training module. And this module is mandatory for all the HACCP team members and highly recommended for all the professionals who work in food industry. The objective of this training is to provide you with necessary knowledge and information about HACCP. In addition to that, this also provides you with knowledge, confidence, and skills required to drive implementation of HACCP in your organization. And I believe this training will increase your credibility as a professional in the food industry. We will be talking about HACCP throughout the presentation, so it's important to know what HACCP stands for. It's called Hazard Analysis Critical Control Point. HACCP is important for any food business because it helps to prevent foodborne illness, and not just that, it reduces recalls and import alerts, which in turn allows the company to save a lot of money from product destruction, hefty fines, etc., etc. And most importantly, it gains customer confidence and driving potential business opportunities to the company. And to further prove this point, I would like to throw in some numbers and infographics. World Health Organization estimated that every single year worldwide, unsafe food causes 600 million cases of foodborne diseases and 420,000 deaths every year, and 125,000 children under 5 die each year. And based on another report of global public health burden of infection, it was observed that though we have more than 250 different food hazards that cause various health issues such as acute or long-term illness or even death, people often get sick from one or another of 31 pathogens causing foodborne outbreaks. And 1 in 10 people fall ill after eating contaminated foods worldwide. And the take-home message from these numbers are foodborne diseases are preventable, and we being in this global food supply chain has a critical role in taking responsibility to ensure safe food to our customers and committed to build strong and resilient food safety system to maintain the safety and integrity of the product in the supply chain for which we are responsible. Now let's learn about HACCP in detail, like how it started and what are the steps involved and what are the principles, so and so. HACCP was first developed in late 1960s jointly by Pillsbury Company, the National Aeronautics and Space Administration, NASA, and the U.S. Army Laboratories, and they collaborated together to build a quality system to ensure food safety for the space program. And in 1974, FDA incorporated HACCP in regulations due to the outbreak of Clostridium botulinum in canned foods. And in 1993, Codex Committee on Food Hygiene recognized HACCP as the global standard for food safety, and the first HACCP guidelines was published by Codex Alimentarius Commission, the joint body of FAO, Food and Agriculture Organization, and WHO, World Health Organization. And from then, HACCP principles have been promoted and incorporated into food safety legislation in many countries around the world. And the Codex HACCP is widely accepted as an essential tool for managing food safety, especially when combined with an auditable management system like BRC, SQF, FSSC 22000, etc. HACCP has a number of advantages for the management of food safety. Firstly, it is globally recognized system and it is science-based and systematic, which allows for specific identification of food safety hazards. And the most important concept underlying HACCP is that it employs the principle of risk assessment, allowing prevention to be based on control program rather than inspection and testing, which saves a lot of time and money. You can think HACCP system is mostly for manufacturers, but it applies to the entire food supply chain, right from primary producers until it gets to the consumer plate. And practically, food hazards can happen at any point in time in the food supply chain from farm to fork. And every single player in the food supply chain, such as primary producers like farmers, processors, traders, distributors, retailers, and even consumers must be responsible to maintain the safety and the integrity of the food they handle to ensure safe food. And to make a point, in recent years, changes in the global legal framework, for example, FISMA, have led to a dramatic increase in the need for developed and developing nations to install HACCP programs and HACCP system to conduct and facilitate international trade. Now let's talk about the principles and steps involved in developing HACCP plan. HACCP principles are defined by Codex and it consists of 7 principles. First, you start with conducting hazard analysis for your process steps. And then you identify critical control points for the significant hazards, followed by establishing critical limits for each identified CCPs. And then you develop monitoring procedures to monitor any loss of control from the critical limits set for each CCP, which is critical control point. And the next step is to establish corrective actions taken when the result of monitoring at the CCP indicate loss of control. And the next step is to develop a verification procedures to evaluate the effectiveness and compliance of the HACCP plan. And the last step is to establish record-keeping procedures in order to demonstrate the adherence of the HACCP system within the HACCP plan. And each principle here is designed to develop the level of understanding of the hazards, their identification, and implementation of the controls. And one of the major observations is that all the food industries, retailers, and regulatory agencies have all adopted these principles and made the requirement of HACCP as part of the schemes recognized by GFSI. And we will be looking at each principles in detail with an example for better understanding. And prior applying these principles to develop HACCP plan for specific product or process, we must follow 5 primary steps. The first step is build your HACCP team. Here you need to put together a team of individuals with the necessary skills, knowledge, and experience to develop an effective HACCP plan. And the nature of the team should be multidisciplinary. For example, in an ideal situation, the HACCP team will represent a member from top management, quality, purchase, sales, logistics, maintenance, production, etc. And depending on the size of the industry, the complexity of the team member varies. And one of the initial tasks of the HACCP team is to clearly define the scope of the HACCP plan, including the product or process to be assessed, and freezing the segments of the food chain that we are responsible, and identify general classes of hazards based on the product and the industry you're involved. And the second step is to describe the products. In order to identify all the factors which can impact on the safety of the product under study, HACCP team must first clearly describe the product, including its composition, physical chemical parameters like water activity, pH, or optimal packaging formula, or durability and storage conditions, and method of distribution. And once you're done with the step, the next step is to describe the intended use and customers. So here, this step is important since the same hazard may impact differently on different groups of population. And for this reason, the intended use should clearly define the type of consumers who may use the product. And also the team will need to include how the product will be used or handled. For example, whether it's ready to eat or it's ready to cook or it requires further preparation by the consumer. And the next step is to construct a flow diagram to describe the process. So here a flow diagram is a graphical representation of the process steps that involve. Hence, it should be comprehensive and cover all the steps in the processes and the defined scope of the HACCP study. And following the construction of the flow diagram, the last step is HACCP team should confirm the flow chart against the actual process flow, and team members should verify and sign the flow chart that is up to date. And once you're done with the steps, then you can follow the 7 principles to develop your HACCP plan. And this is a typical example of a completed product description form for frozen blueberries, where you can see the scope is clearly defined, where it starts from sourcing, processing, storage, transportation, and delivery. And you can also see a short summary of the process and the relevant product characteristics, which is storage temperature, pH, Brix for this product type. And you can also see the type of packaging used, the shelf life is mentioned, and the product to be sold, whether it is only domestic or it involves international, wholesale, or retail markets, etc. And even the labeling instruction is clearly defined in order to avoid any non-compliances with respect to labeling standards. And the intended use is clearly defined here as well, where you can see this product is sold for further processing or repacking or used as an ingredient in baking or consumed frozen by the consumers. If the product is thawed, it has to be consumed immediately or to be refrigerated at 4 degrees Celsius for 72 hours max to avoid any proliferation of microorganisms. And even the controls are mentioned during the phase of transport and distribution, where the product should be maintained all the time below minus 18 degrees Celsius throughout the supply chain until it gets to a customer location. So here you could see we captured all the steps we mentioned in the previous slide. And this is the simple process flowchart for a frozen food processing manufacturer. And we're going to take one of the steps in the process to discuss each principles we saw in the previous slides. It starts with raw material receiving, sorting, grading, washing, packing, metal detector where you pass the packed products in the metal detector. Then it goes to freezing, frozen storage, transportation, and delivery. So now let's discuss each principles in detail. The first principle is to conduct hazard analysis. So first, we list all the steps involved in the process and identify potential hazards. And as we've seen previously that HACCP system identifies the potential hazards and controls at specific points in the process. These includes 3 main categories of hazards, which is biological, chemical, and physical. Biological hazards include microbiological organisms such as bacteria, virus, fungi, and parasites. And many of these organisms occur naturally in the environment where the foods are grown, and the most are killed or inactivated by cooking, blanching, and its numbers can be minimized by adequate control of handling and storage practices. And on the other hand, viruses can be foodborne or waterborne or transmitted to food by human or animal or other contact. And unlike bacteria, viruses are unable to reproduce outside a living cell. Hence, they cannot replicate in food and can only be carried by it. And you can see common pathogens on each category. For example, Listeria, Salmonella, and E. coli are well known for outbreaks. And chemical contaminants in food may be naturally occurring or may be added during the processing of food. And based on several studies, ingestion of harmful chemicals at high levels have been associated with acute cases of foodborne illnesses and can be also responsible for chronic illness at lower levels. And some of the naturally occurring chemicals are allergens, mycotoxins like aflatoxins in peanuts, patulin in apples, mushroom toxins, shellfish toxins, and some of the examples for added chemicals are pesticides, fertilizers, antibiotics, heavy metals, or the contaminants like lubricants, cleaners, sanitizers, or even prohibited substances like food additives at higher dosage or higher concentration, etc. And even chemicals can leach from the packaging material into the food, for example, plasticizers, adhesives, inks, lead, tin. And the last one is physical hazards. And these physical hazards, like wood, plastic, bone, metal, stones, glass, etc., can result from contamination and or poor practices at many points in the food chain from harvest to consumer, or even including those within the food establishment could be a potential source for those occurrences. And ingesting hard foreign objects can lead to injury and illness. And you can gather information about potential hazards associated with a specific food from a variety of sources. For example, like reference texts, websites, food safety standards, codes of practices, legislation, company complaint files, or scientific research and review papers, or epidemiological data on foodborne illnesses or disease. And from these resources, you can fetch and gather information about specific hazard that could possibly occur in a specific product type. After listing all the hazards that may be reasonably expected at each step in the process, then you conduct hazard analysis for each step based on the application of risk assessment to identify the significant hazards. And during this process, it is important to consider several factors based on the information you gather for each hazards. Like, for example, what are the likely occurrence of the hazards and what are the severity of their adverse health effects, and how we evaluate the presence of hazard, whether it is qualitative or quantitative, and what are the optimal conditions for the survival or multiplication of the pathogens in food, etc. And after the hazard analysis is completed, then the team must then consider what control measures, if any, exist, which can be applied for the control of each hazard. Let's do hazard analysis for one of the process steps, which is metal detection. And here, the type of hazard that is involved is physical. And the description of the hazard is metal fragments. It could be from external or internal source. So once you identify the type of hazard and describe the hazard that's involved, then the next step is to assess the risk involved at this step using a risk assessment matrix. And here you can see a typical risk assessment matrix table where the severity, the risk of the severity is on the x-axis and the risk of the likelihood is on the y-axis. And it is rated from 1 to 5, where 1 is a low risk and 5 is considered a high risk. And each ratings from 0 to 5 is defined clearly. So this is considered as a risk assessment matrix, which we will be using to assess the risk involved. And usually the estimate of the risk for a specific hazard is based upon a combination of experience, epidemiological data, and information in the technical literature. And here, the multiplication of the risk probability by a risk severity will give you a numerical estimate of risk. And based on the risk table, the score is given 4 and 4 for the probability and severity, considering its high probability of occurrence and the risk of severity involved at this step. And when you multiply, it gives 16, which falls under the category of intolerable risk, and the risk is considered as high. And the next step is to mention the control measures. So here some of the control measures are passing the final product through metal detector and periodical checks for the processing equipments to identify any damages or missing parts, and periodical calibration and maintenance to make sure the equipment are in good condition and runs properly, and to control all the metal inclusions within the facility or processing unit. And here, a point to be noted is HACCP system is focused on significant hazards of such a nature that their prevention, elimination, or reduction to acceptable level is essential to the production of a safe food. And in cases like hazards of low probability of occurrence and a low severity should not be addressed under the HACCP system, but may be addressed through a good manufacturing practices and all the other prerequisite programs suggested by Codex General Principles of Food Hygiene. Like some of the examples of prerequisite programs are sampling and product testing, pest control, or cleaning and sanitation, etc. So now let's move on to another example. And here we consider freezing, which is another process step that we saw in the flowchart. So here the type of hazard is biological and the description of the hazard is growth of pathogenic bacteria. And the score for probability and severity is pretty much the same. Like here it's given 4 and 4 based on the risk matrix table, and the risk is high. And some of the control measures for this particular step, considering the hazard, is to maintain the record of the product temperature all the time less than minus 18 degrees Celsius throughout the process, and to provide alarms to indicate temperature abuse, and to inspect and record product temperatures at set frequency and intervals. Now let's move on to the second principle, which is to identify CCP or critical control point. And CCP is a step at which control can be applied and is essential to prevent or eliminate food safety hazard or reduce it to an acceptable level. And here we use Codex decision tree, which indicates a logical reasoning approach to determine the critical control point. And there are 4 questions in this sequence to determine a specific step as CCP. And in the previous slides, we did hazard analysis for a process step called metal detection, and we found the risk is high and is considered as significant hazard based on the risk matrix. Now let's ask these 4 questions to determine whether this particular step is a CCP or not. You can see 4 questions in the table, and for the step metal detection, the interpretation of question 1 is basically whether or not a control measure exists to control the identified hazard. For example, temperature control, product testing, cleaning and sanitation, or using a metal detector. And as you know, as you saw in the previous slides, we do have control measures for this particular step. So our response to this question is yes. And Q1A is a supplementary question to question 1, which is control at the step necessary for safety. And the answer is yes. So if the response is yes to question 1, then you proceed to question 2 in the decision tree. If the response is no, which is basically like there is no control measures exist, then we need to indicate how the identified hazard will be controlled. If the process or operation is specifically designed to eliminate or reduce the likely occurrence of the hazard to an acceptable level, then you answer yes under question 2. Here, metal detection is specifically designed to remove metal fragments, hence we answer yes to this question. When you answer yes to question 2 and no to question 4, such step will automatically becomes a CCP. And once you identify a particular step as a CCP, then you need to define the acceptable and unacceptable limits, which we will be seeing in the following slides. If the answer is no to question 2, then you proceed with question 3. Question 3 refers to both likelihood and seriousness of the hazard, and mostly the response to this question is a judgment call based on the information and literatures we gathered about the hazard. If data suggests that contamination with the identified hazard may increase to an unacceptable level and result in an unacceptable health hazard, then you need to answer yes and proceed to the next question in the decision tree. If the contamination is not known to present a substantial threat to human health or is not likely to occur, then you answer no, which is not a CCP, and you proceed with the next identified hazard in the process. In this case, question 4 is not applicable because we answered yes to question 2, which makes the step automatically CCP, and it stops the flow of the decision tree. And the next question, this question is designed to identify those hazards that could pose a health risk will be controlled by a subsequent process operation. If no subsequent operation is scheduled in the process to control this identified hazard, then you answer no, and this particular process step becomes a CCP. And if you answer yes, then this particular step is not a CCP, and specify how and where that particular hazard will be controlled, and proceed with the next identified hazard. Again, this question is not applicable for this process step, as we already confirmed this step as a CCP based on response to question 2, which is yes, and it automatically makes the step a CCP. Let's review this table where the 4 questions are already answered for one of the other process steps, which is freezing. This step has control measures, so we answer yes. And the step is necessary for safety, so we answer yes again. And the step was not specifically designed to eliminate the hazard, so we answer no. And for question 3, we answer yes because, say for example, if the product temperature is not maintained well, then there is a high possibility or chances for the microbial contamination. So we answer yes to question 3. And for question 4, the response is yes, because if you remember in the process, in the product description form for frozen blueberries, we mentioned that the product will be sold for further processing, which means this product will be handled by another processor before it gets to the retail. So based on the responses, this particular step is not a CCP. When you decide or figure out that a particular step is not a CCP based on a decision tree, then that step has to be controlled by prerequisite programs or operational prerequisite programs. And we need to specify which PRPs will be taking care to control that identifier hazard in the particular step. So in this case, the PRPs are receiving and storage, equipment maintenance, personal training. So once you're done with CCP determination for all the process steps, then you move on to the next principle, which is establishing critical limits. A critical limit represents the boundaries with maximum and or minimum value to which a biological, chemical, and physical parameters are controlled in order to judge whether an operation is producing safe products. In general, critical limits must be measurable and observable. For example, temperature, time, sensory tests, etc. And these parameters, if maintained within the boundaries, will confirm the safety of the product. In some cases, more than one critical limits may be required. For example, in blanching process, we need to monitor both time and temperature. And these are the common examples of CCP and its critical limit in food industry. For example, a metal detector. The type of hazard is metal fragments, and the critical limit is any metal fragments that is larger than 0.5 mm is considered as an hazard. And another example is pasteurization, where the critical limit is 72 degrees Celsius for at least 15 seconds to kill the pathogenic microorganism in the product. And every critical limits that are established should meet requirements of government regulations and or company standards and or to be supported by other scientific data. Hence, it is very imperative that the person responsible for establishing critical limits must have knowledge of the process and of the legal and commercial standards required for the product. You could use several resources to gather information on critical limits, for example, scientific publications or research data or regulatory requirements and guidelines or experts' opinion or experimental studies or in-house experiments or contract laboratory studies. And for some reason, if the information needed to establish critical limit is not available, then a conservative value should be selected based on experimental studies or use a regulatory limit close to the similar product. All the rationale and reference material used in this process of establishing critical limits should be recorded. Let's complete the critical limit for the identified CCP. Any product that continues to have metal fragments of ferrous greater than 2 mm, stainless steel greater than 3 mm, or non-ferrous greater than 2.5 mm is considered as the hazard. And once you're done defining the acceptable limits for the CCP, you move on to the next principle, which is to establish monitoring procedures. The monitoring procedure will determine if the control measures are being implemented and ensure that critical limits are not exceeded. And HACCP team have described the monitoring procedures for the measurement of the critical limits at each critical control points. And this step is key because it helps to measure the performance level of the system's operation at the CCP, which in turn help to do trend analysis and to determine when the performance level of the system results in a loss of control at the CCP, and to establish records that reflect the performance level to comply with the HACCP plan. And the monitoring specifications for each CCP should be documented, and all the records and documents associated with monitoring CCPs must be documented and signed by the person doing the monitoring and by a responsible reviewing official of the company, like the QA supervisor or manager. And you'll see the importance of record keeping in detail in the following slides. There are a few key elements to be considered while designing a monitoring plan for a CCP. Checking protocols have to be real-time, short, and should not involve any lengthy analytical procedures. And all the 5 questions to be addressed for each monitoring step, like what is measured or evaluated during monitoring, or how monitoring activity of a critical or legal limits will be conducted, or when and how often checks will be done, or who is responsible for performing, or where will the results of monitoring be recorded. And in addition to that, we also have to address who will check that monitoring is being carried out properly, and where and how is this check to be recorded. Let's complete monitoring plan for any presence of metal fragments in the product. And as I mentioned earlier, we need to address those 5 questions. So here, the response to the first question is we will be monitoring for any metal fragments such as ferrous, non-ferrous, or stainless steel in the product that are greater than the size specification mentioned. And we will be monitoring based on the SOP XYZ specific to the company, where basically we first calibrate the equipment by passing a testing piece through the detector to see if the detector able to reject the minimum amount of the metal. And once that's done, you basically pass the product along with the test piece to see if the detector able to detect the metal sample in the product. And finally, operator must ensure for proper functioning of CCP by checking if the alarm sound works properly, or if the air pressure is good enough to kick the bags out from the line, and if they could able to shut down the line. And the response to next question is operator will test the metal detector at the start and every hour during packaging and at the end of each packaging run. So this is basically to calibrate the machine at set frequency. And for the products, all the products will pass through the metal detector continuously through automatic screening. And the response to next question is the monitoring procedures will be conducted by a bagger operator with required training given to the person. and the operator will record results on Form XYZ monitoring record specific to the company, and they have to include initial date and time. Once that's done, the monitoring records will be reviewed by the QA supervisor or the manager at a set frequency or set intervals according to the company policy. And once we are done with establishing monitoring procedures, we need to establish corrective actions, which will be discussed in principal file. When the result of the monitoring at the CCP indicates a loss of control, immediately actions to be taken to control the non-compliant product and to correct the cause of non-compliance. And this process involves two steps, which is deviation and corrective action. And all the food business operators should have a system in place to identify deviations when any non-conformity occurs and should have effective procedures in place to isolate and mark clearly and control all product produced during the deviation period. And the evaluation of affected products should be conducted only by subject matter experts with relevant experience, and the final decision should be based on sound science, and the product is not released until evaluation has determined that no potential hazard exists. Since the main reason for implementing HACCP is to prevent problems from occurring, corrective action should be taken to prevent deviation at the CCP. Corrective action should be taken following any deviation to ensure the safety of the product and to prevent recurrence of the deviation. Let's complete a corrective action plan for the identified CCP. So here, when a metal detector fails to detect a metal test sample, we need to immediately stop the line and place all the product process since the last successful check on hold until they pass through a functional metal detector. When a product is rejected by the metal detector, then we need to contact the plant supervisor and investigate whether metal came from and record all the non-conformities and corrective actions taken. Our sixth principle is to establish verification procedures. Verification step is essential to confirm whether our HACCP system works effectively and in compliance with the HACCP plan. And some of the verification activities are validating your HACCP plan, periodic audits, equipment calibration, random sampling and analysis, etc., etc. And validation by definition is to confirm the efficacy of all the elements in HACCP plan. And here you can see the verification plan defined already for the identified CCP, where you can see at end of each production day, QA must review the metal detector check record to ensure that it has been done properly and it completed properly. And once per week, QA manager observes the line operator monitoring function to ensure the written procedures are being followed and signs and dates of the forms are properly maintained. And in addition to the above, the QA to annually verify certification of all the calibration and maintenance of the metal detectors. And if any deviations are found for any of the above procedures, the QA manager initiates corrective actions. So it is important, in addition to the verification steps, it is important to validate the HACCP plan to assess whether the derived HACCP plan for a particular product and process adequately identifies and controls all significant food safety hazards to an acceptable level. Generally, validation of HACCP plan includes activities like reviewing the hazard analysis and CCP on annual basis and justification for critical limits based, for example, current good science and regulatory requirements, and determination of whether monitoring activities or corrective actions or record keeping procedures and verification activities are appropriate and adequate. And finally, we need to record all the observations on the daily metal detector check record, including date, time, and initials, because this is very important to determine or to demonstrate the adherence of the HACCP system. Our last principle is to establish record-keeping procedures. Records may be in any form, for example, processing charts, written records, computerized records. It's imperative that the company maintains complete, current, properly filed, and accurate records. There are 4 types of records should be kept as part of the HACCP program. The first one is support documentation for developing the HACCP plan. For example, any documents, data, and information used to establish the control measures or documents supporting adequacy of critical limits or document of hazard analysis, etc. And the second type is records generated by the HACCP system. For example, monitoring records for all CCPs, deviation records, corrective action records, or verification or validation records. And we also need to document the methods and procedures we used in the HACCP system. And finally, the records of employee training programs. Let's complete record keeping for the identifies CCP. From this table, you can see what type of records is required for the identifies CCP. Say like monitoring records, deviation records, corrective action records, and maintenance records. And this is the summary of the HACCP plan for the identified CCP, which is metal detection, and the metal fragments, which is the type of hazard that we are controlling at this step. And this includes all the key elements of the HACCP principles we discussed so far. And the same procedure is followed for any identified CCPs within the process. So I'm happy to say that with this, I conclude my presentation. Yes, we completed and went through all the important aspects of the HACCP system. I hope this session was informative and thanks for your time. You have one more responsibility before you officially say you're done with the session. Yes, it's time for the quiz. Remember that training assessment record is one of the records that we need to maintain to demonstrate our compliance. So you can access the quiz either by clicking the link that was already sent to your email, or you can use the QR code to get to the quiz. I'll be waiting to receive your responses. I'm excited. And if you have any questions, please don't hesitate to contact me at any time. I'll be happy to answer you back. Thank you so much and have a good day. See you.